Hi, my name is Annette. Welcome to our latest format, Lunch and Learn. With this new format, we want to provide you with digital bites that enrich your daily business and provide you with concrete tips and tricks to become a digital frontrunner in the process industry. Only take 50 minutes anytime and anywhere you want and just become a little bit smarter. To do so, today I will talk to our super smart colleague Taede, who is a senior consultant at Bilfinger Digital Next. Hi, Taede.
Hi.
Taede has a lot of experience in managing and digitalization and data-driven projects at customers. So he knows a lot about the production process. However, he's not a data scientist himself. So to overcome this little gap here, he will today talk about how to run easy preliminary analysis without deep data science knowledge. But before we start in detail, Taede, just tell us a little bit more about yourself, please.
Okay, thanks Annette. Welcome to this learning session. So about myself, I have background in applied physics and mechanical engineering. Currently, I work as consultant digital transformation at Bilfinger Digital Next. As a company, we strive to digitalize the process industry. My favorite part of the job is to look at and to analyze data provided by the customer. And together with the customer to come to actionable insights and recommendations. And in this session, I want to show an example where we're able to show this insights to the customer. And this is what you will learn from it is maybe it's good to know that I work in the process industry for 7 years now, so I have a good understanding of the different processes. However, my data science skills are limited. So I want to show when you have process data available, you can still easily and quickly come to insights of your process without the need for deep data science knowledge. And I will describe this with a use case. It's something we did last year. So a pharmaceutical company contacted us. They were interested in increasing their production capacity, and they knew of our capabilities. Together with the help of our data scientists, the idea is to automatically identify the filter idle time and as such show the available spare capacity. However, to be able to do this, you need to write a script, and for that we need to know how you can identify batch. And this batch should be identified based on process sensor values. We did have production data available, but the timestamps did not have the right level of detail. So we could not link the production data directly to the sensor data. Also, our contacts at the customer were not able to tell right away the exact characteristics of the batch and individual steps. So what to do? In order to answer this, it's good to know which information I had available. So first of all, I had data from 10 sensors available for 1 year with a 1 minute interval. Second, I had production data available. And thirdly, I had some process drawings available. And these help me to understand the process and also the meaning of the sensors. Let's now look at the process shortly. So first of all, when a batch starts, the filter is filled with solvents. The solvents are mixed with an agitator, and the insides of the filter are kept at the right temperature by means of a heating jacket. And this heating jacket is cooled up or cooled down and heated up by means of a cooling or heating medium. The pressure inside the filter can also be regulated, so you can apply a vacuum or you can increase the pressure by applying nitrogen pressure. And finally, when the product is finished, when it's dried sufficiently, then the product is discharged at the bottom of the filter. And now which sensors were available? So first of all, the temperature of the filter. Second, the temperature of the jacket. The pressure of the filter was available, and finally the speed of the agitator was available. So these are the 4 I looked mainly at. There were 6 others, but those were less relevant for identifying the batches I found out during the analysis. So that's the information I had available. And now let's see if we can identify the batches and individual steps. For this, I will open up a tool called TrendMiner. This is a well-known tool within the industry. It can be used to explore and analyze time series data in a fast and user-friendly way. So let's open it up. So here we have TrendMiner. On the left, you can see the 4 sensors I used. So that is the pressure of the filter, the speed of the agitator, the temperature of the jacket, and the temperature of the filter. Now also first select a bigger time range. Okay. So what we see here now is 1 year of sensor data. The sensors are now all in one plot, but I'd like to show a stacked trend. It looks like this. So on the top we have the pressure of the filter. Then we have in pink the speed of the agitator. And at the bottom is the temperatures, and I'd like to combine these in one graph.